Hello! Welcome to Stepping Out, where we help you answer conundrums in physics. Our topic for today is free fall.
So what is free fall?
In physics, free-falling motion is defined as a motion where an object is allowed to fall freely under the effect of gravity. The superhero Green Lantern steps from the top of a tall building. He falls freely from the rest of the ground, falling half of the total distance to the ground during the last 1 second of his fall. What is the height of the building?
Since Green Lantern is falling freely from rest, we know that our original velocity is equal to 0 meters per second.
Since this is a free-fall problem, we also know that the acceleration is equivalent to the gravity, which is negative 9.8 meters per second squared.
Now here's the catch. We are only given the time for the second half of his fall, which is equal to 1 second, but we are asked to find the height.
This step is completely optional, but to make things easier in this free fall scenario, we are going to reformulate the problem into a more general timeline with x the displacement from the starting position as shown below.
We know that he starts with 0 velocity at the time 0. Halfway down the building, he has traveled h over 2 meters, but we do not know how long it took him to arrive at the halfway point.
At the end point, we know that the total time is equal to the first half of the fall plus 1 second, being the second half of the fall.
The total displacement is h. Because of this, we divide this problem into 2 segments.
For the first half of the fall, we have the following equation for motion with constant acceleration.
Substitute the known values, original velocity being 0, acceleration being negative 9.8, the original position of the hero being 0, and the halfway point being h over 2.
This is what you get when you substitute the known values to the equation. After everything's been simplified, we know that the velocity during the first half of the fall is equal to the square root of gravity times height.
For the second half of the fall, we derive another equation of motion.
When you substitute the known values, this is what you get.
Subtract h over 2 from both sides to tidy things up.
Since we know that v sub 1 is equal to square root of gh, we can now substitute it into the equations.
Now, we multiply both sides by 2 so we can eliminate the denominator.
We now have an equation where the only unknown is h. Remember that we can factor the equation and express it as the following.
Notice that the equation can be converted into quadratic form if you substitute square root of h with alpha. All you have to do is rearrange the equation.
Now we can solve this using the quadratic formula, negative b plus minus square root of b squared minus 4ac over 2a, where a is equal to 1, b is equal to 2 square root of g, and c is equal to negative g.
Substitute the known value to the formula.
At this point, you may solve for the answer quickly using your scientific calculator. However, for the sake of those who don't have, this is the manual way to do it.
The quadratic equation gives us 2 possibilities for h. We recognize that the displacement cannot be negative. We define the acceleration to be in the positive direction, and since we are starting from 0 velocity, we cannot end up with a negative displacement.
And that is how you can solve the problem. Thank you for watching.